Okay, so now we're going to start our intermediate equations. Mr. Singh wrote this equation on the board. What is the solution to this equation? As you notice, we don't have any multiple choice here. So we're actually going to solve it, and then we're going to go ahead and put it in our calculator to check it. Just so I don't forget that I'm going to check it, I'm going to go ahead and put it in first because I do not want to make a mistake. I know that n is going to have to equal something. If I still need to use my calculator, I can. In this case, I'm going to go ahead and start solving. I'm going to make that fraction a decimal, so I've got 0.25 times 2n minus 28 equals 10. So 0.25 times 2, like I said, if you need to use your calculator, I would definitely suggest it. I would always say use it just to make sure you don't make any silly mathematical errors. It gives you 0.5n, which you never want to do when you've got a calculator right in front of you. Why would you make that mistake? So let's put in 28 now, and you get 7, so that's a negative 7 equals 10, because you've got positive 0.25 times negative 28. I'm going to add 7 to both sides of my equation. 0.5n equals 17. And remember, don't just start working on one side of the equation and not the other. Always keep them even. That way you don't make any mistakes. So I'm going to come back over to my calculator and put in 17 divided by 0.5, which gives me n is 34. So what I'm going to do is come up here in my calculator, put in 34, and see if it gives me 10. It does. So that means that I am correct. You always want to check every single answer. Don't miss them because you won't check them. Let's go ahead and solve this equation. I'm going to come back over here. I'm going to go ahead and clear everything. I'm going to put in negative 2m on one line. I'm going to put in 3 times m minus 10 on the next line. And the third line, I'm going to put m equals, and I'm going to figure out what that's going to be. First thing I have to do is distribute. So I've got negative 2m equals 3m minus 30. And then I'm going to add, actually I'm not going to add 30, I'm sorry about that. I'm going to move my 3m over and get all my variables on one side. So I have negative 5m equals negative 30. Now I'm going to divide each side by a negative 5, and that says that m is 6. I'm going to come back to my calculator and make sure that 6 makes both sides of that equation equal. It does. They are both negative 12, so I know that I am correct. Never, ever, ever forget to check. It's there for you to use. Take full advantage of that calculator. All right, this is one of the problems that we taught you early on called Slay the Dragon, Save the Princess. So I'm going to start by drawing my line. Or actually, I'm going to start by putting in my calculator so I don't forget to check. I'm going to use this A divided by B button because that makes it a lot easier when you've got expressions as a numerator and or a denominator. Put in the 2 there. I'm going to say minus 3. And then I go on to the next line, and I know that my x is going to have to give me 19. So I'm going to put an x equals there and go to the next line in case I need the calculator for anything. So the first thing I'm going to do is slay this dragon. I'm going to add 3 to each side because I want the dragon gone. So I've got x plus 4, which I'm going to put in parentheses to keep the princess safe. And that will equal 19, 22, okay. That'll equal 22. Add 3 to 19. Now I'm going to get rid of this 2 in my denominator by multiplying each side by 2. Oops, sorry about that. It cancels out here. And I end up with x plus 4 equals 44. I'm going to subtract my 4 from each side, and x equals 40. So I'm going to come over here to my calculator where I'm checking. I'm going to put in a 40, And my answer is 19, exactly what it should be. So I know that I have solved this correctly. Again, use the calculator to the full extent possible. So, this is another intermediate problem. So we're going to start by looking at our key. A small square, white square is a 1. A white rectangular, oh my goodness, a white rectangle is x. A black small box is -1, and the black rectangle is a -x. So I know that this is -x, this is -x. There are 8 boxes, each valued at 1, so I'm going to put a +8. These are each worth x, and then there are, yes they are. And then each of these black squares is a -x, and if you notice, or the small black squares is a -1, I'm sorry. So there are 10 of them, so that would be a -10. So it would be -2x plus 8 equals 4x minus 10. And if they asked you to solve that equation, again, the first thing I would do is put it in my calculator. That would be on one line. My next line would be the 4x minus 10. And I know my x is going to have a value, so let's go ahead and solve and see what we can do. I'm going to move that 4x over by subtracting it from each side. That gives me -6x plus 8 equals -10. I'm going to subtract 8 on each side, which gives me 2. And then, let me make sure I've done all that correctly. Oh, I'm sorry, that was a -10, and subtracting an 8 actually gives me -18. So let me fix this. That's a -18. I apologize for not writing everything down. I'm just trying to save some room here. So now I have to divide by -6, so that means my x is going to equal a +3. So let's see if x equaling a 3 makes those two sides the same. It does. It makes them both 2. So I not only wrote the equation, but I definitely checked it as well. Okay, we've got another one that we need to read and see what it's about. It says Eric solved the equation x minus 3 equals 10 is shown. What property justifies what happened between step 1 and step 3? If you notice right here, that -3, he added a 3 to both sides, which would be your additive inverse. Let's go to the next one. It says between which two steps is the associative property of addition applied? So let's see, where's the associative property of addition? Associative means that my parentheses have moved. Up here, they have a switch. 3x goes from the beginning to the end, so that's actually commutative. Between 2 and 3, we've got parentheses around the 12 plus 5x, and then they move to be around the 5x plus 3. So right here is where we see the associative property of addition. Okay? So let's go ahead and try our next one once I get my screen back. Just give me a second, I'm sorry. Alright. Not sure where that went, so